Welcome to this Abdul Hadi AI World Explainer. I am so thrilled you're here today because we're going to unpack something absolutely fascinating. We hear about artificial intelligence literally every single day, right? How it's shaping our world, how it makes decisions, and how it analyzes our lives. But how do we actually ensure those algorithms are fair? Well, the secret to building ethical AI doesn't just lie in millions of lines of complex code. It actually relies on foundational statistics. That's right, the mean, the median, and the mode. Let's jump right in. So, what really happens when an AI learns from bad data? We've all seen the headlines about algorithms making totally unfair decisions, whether we're talking about biased hiring software or skewed loan approvals. But here's the thing, the algorithm itself isn't actively trying to be malicious. Not at all. It's simply reflecting the poor data handling it was trained on. Think of it as a direct cause and effect. On one hand, when we use wrong statistics, we fundamentally bake bias into the AI's predictions. The AI is just going to blindly repeat our mathematical mistakes. But on the flip side, when we apply correct, rigorous statistical analysis, we dramatically improve the fairness of those outcomes. It's like flipping a switch from biased to balanced. Here is our roadmap for today's explainer. We'll cover point 1, AI's hidden bias problem, then move to 2, mean, finding the trend. Next is 3, median, taming extreme values, and 4, mode, identifying common patterns. We'll wrap up with 5, building ethical AI models, and 6, Abdul Hadi's global vision. Okay, section 1, AI's hidden bias problem. The really crucial thing to remember is that an AI does not have human common sense. When we feed an artificial intelligence unbalanced or misunderstood data, it doesn't know how to step back and say, hey, wait a minute, this doesn't look right. Nope. Instead, it magnifies those flaws at lightning speed into really unfair outcomes. If the statistical foundation is cracked, the AI builds a structurally unsound, biased worldview. Basically, we have to fix the math to fix the machine. Let's move to section 2, mean, finding the trend. We're going to start with the mean, which most of us just call the average. This is an absolutely essential tool for helping an AI understand the general tendency of a massive dataset. Instead of an algorithm getting completely lost in thousands or even millions of individual, noisy data points, the mean helps it find the center of gravity. It shows the overall trend. It's kind of fascinating how looking at something as simple as student marks helps an AI learn fairness. Think about a classroom with low, average, and high marks. By calculating the mean, the AI finds the true average performance of the whole room. It gives the algorithm an unbiased starting point, making sure it doesn't judge the entire class based solely on the one student who really struggled or the one valedictorian who got a perfect score. It finally sees the whole picture. Section 3, median, teaming extreme values. Now, sometimes averages can be incredibly deceptive, which brings us to our next statistical hero, the median. When wild outliers threaten to completely skew an algorithm's understanding of reality, the median acts as a vital stabilizing force. It just finds the absolute middle point of your data, perfectly dividing the higher half from the lower half. Imagine training an AI on income data, where you have low earners, middle earners, and then, boom, a massive extreme outlier, like a billionaire living in a normal neighborhood. If we're using the mean to grant loans, the AI would think everyone there is super rich, potentially denying loans to people who desperately need them. But using the median instead, the AI ignores that extreme billionaire outlier and understands the true middle ground reality of that neighborhood. Fairness is totally preserved. Section 4, mode, identifying common patterns. Finally, AI needs to understand frequency, and that is exactly where the mode steps in. The mode is a really powerful way for AI to categorize data without imposing false averages on entirely distinct groups. It simply identifies the most common pattern or the value that shows up most frequently in your dataset. Let's say we're analyzing customer behavior data that's split into a few distinct segments with one clearly dominant habit. This is the mode in action. If an AI is trying to predict what a customer actually wants, averaging out someone who buys shoes and someone who buys hats gives you a meaningless middle that represents literally nobody. But by examining behavior using the mode, the algorithm clearly identifies the most frequent specific patterns. This ensures its decisions reflect actual human habits, rather than just mathematical ghosts. Moving on to Section 5, building ethical AI models. This concept right here is the absolute heart of ethical AI.
Using the right statistical tool directly translates into a fair and balanced model. We simply cannot treat data as a black box. If we lazily apply the mean to data with extreme outliers, we get bias. But if we smartly apply the median and mode where they actually belong, we achieve fairness. At the end of the day, the math dictates the morality of the machine.
So, how does this translate into an actual engineering pipeline? Well, step 1 is gathering that messy, raw data. But step 2, this is where the magic happens, is applying our correct statistical analysis using mean, median, and mode. This transforms the raw data into step 3, a mathematically clean dataset. And only from clean datasets can we reach step 4, ethical AI development. You just can't skip a step and expect a fair outcome. Section 6, Abdul Hadi's global vision. Understanding all these statistical foundations leads us to a much larger global mission. To truly innovate and change the world for the better, we have to emphasize 3 non-negotiable pillars. We require clean data, we require balanced data sets, and we absolutely demand ethical AI development when constructing the technologies of tomorrow. And this is why it all matters so much. When we train AI with fairness, precision, and the right statistics, we unlock Abdul Hadi's ultimate goal, using technology and education to fight poverty and open doors worldwide. A biased AI might unfairly deny someone an opportunity, sure, but an ethically trained AI, grounded in really sound mathematics, can distribute educational and economic resources fairly across the entire globe. By mastering the data, we're literally empowering humanity. If you found this breakdown of AI fairness fascinating, be sure to subscribe to Abdul Hadi AI World and explore AI learning with us. Understanding the statistics behind the algorithms is the very first step to building a better future. So I'll leave you with this provocative thought. Are we going to let algorithms shape our tomorrow with hidden mathematical blind spots? Or are we going to demand the statistical precision that guarantees a fair and ethical world for everyone? Thanks so much for joining me on this explainer, and keep questioning the data.